Now we finish the chapter off with the 4.5, what are called equations. Because logarithms and exponents are inverse of each other, essentially they're going to cancel each other in an equation. So that's what we're going to look at in this section. We're not going to do 4.6 for this test, just up to 4.5. So there's two one-to-one properties that say if you have a to the x equals a to the y, then x equals y. In other words, if you have an equation where you have two bases that are the same, then the powers have to be equal. Like number one says, if 2 to the x equals 2 to the fourth, then the bases of 2's match, so x has to be 4. If 3 raised to the 2x minus 9 equals 3 to the x plus 5 because the bases match, the powers have to be equal, and you just solve for x. The second one says if you have two logarithms that are equal with the same base, then the stuff inside the logarithms are equal to each other, like number 3. If log base 2 equals of x plus 1 equals log base 2 of 10, then x plus 1 should equal to 10. So you subtract 1 from both sides, and then you get x equals 9. If these bases are different, then you can't use these properties. If they're different, you're in a world of pain. I won't do that to you this semester. I'll make it nice and neat, nice and understandable here, hopefully for this part. So number 4 has log base 3 of 5 plus log base 3 of x plus 1 equals log base 3 of 15. Now there are 3 logarithms. I need a log equal to a log. So I'm going to use what I did a little while ago, or a previous section. Remember, at logarithm of 2 logarithms added, I can break it into 1. I can condense it using the properties of logarithms. So addition goes to multiplication. So it becomes 1 logarithm. So now you have log base 3 of this stuff equals log base 3 of this stuff. So these two things are equal. So 5 times x plus 1 equals to 15. If you distribute by 5, and take away 15, and then divide by 5, you get x to be 2. Kind of a real nice problem. Just the stuff inside equals the stuff inside. But before you can do it, that's why we learn how to do condensing, to be able to make this thing a little easier. Well, if addition went to multiplication, subtraction should go to division. So if log base 3 of x plus 1 divided by x minus 5 equals log base 3 of 5, then this fraction should equal 5. And then to get rid of the bottom, multiply both sides by x minus 1 to cancel. This distributes, you get 5x minus 5. Move the 5x over, and then move the 1 over, and then divide, and you get x equals 3 over 2. And so that's how you solve logarithm problems using the one-to-one property, and how you solve exponential equations using the one-to-one property. Those are straightforward. Those are really nice. So let's try a different property that doesn't have that. So if it's not one-to-one, then essentially what can you do? Well, the thing is, you're going to have to try to cancel things out. So there are two formulas, or two properties that say if you take the log base a of a to the x, x is your answer. Which means essentially these things cancel. I'm not going to actually write the canceling there, but that's what happens. If you have a number raised to a log of the same number of x, those things cancel and you get x as your answer. Let me show you what I mean here. So if I have this equation, it's an exponential equation. It's an equation that has an exponential as an x as the variable as an exponential as an exponent. Subtract 5 from both sides first, you get 15. Now here, you want to get to the x minus 1, so you got to cancel the 3. But notice, it's not 3 times x. It's not 3 minus x. It's not 3 plus x. It's not 3 divided by x. It's 3 raised to the x power. So you got to multiply something, or you got to bring in something that cancels the exponent. Well, rule number 1 says a logarithm cancels with a base, with an exponential. So that base is a 3. So if I bring log base 3, if I do the same thing on both sides, that's legal in math. These things will cancel as this thing says. and all that survive is the power, so x minus 1. So that's why they're called cancellation properties, because they cancel. On the right, you have log base 3 of 15. Now, adding 1 to both sides becomes 1 plus log base 3 of 15. Once you get x by itself, essentially that's the answer. But you got to, this, we have no button for this in your calculator. We have no little 3. So a little while ago, or earlier, we learned about the change of base formula. Put the 15 on top, put the 3 on the bottom, and either do log log or ln. So you have 1 plus natural log of 15 divided by natural log of 3. I guess, yeah, I'll show you how to do this in the calculator. But I want you to see that I did it 2 different ways. I did it 1 plus natural log of 15 over natural log of 3 and change of base with natural log. And the same problem with the change of base with logarithms. One you to see is the same answer. So essentially we'll go with the first one. So I believe I went, what, 3.465. So I went 3 decimal places. Okay. Number 2, you want to get the exponential base by itself. But to do so, you got to move the 10, the negative 10. So the opposite of minus 10 is plus 10. So 2 raised to this power is 40. So to cancel an exponential base, you bring in a logarithm. So this is log base 2 to both sides. Log 2 and 2 cancel. So x plus 3 equals log base 2 of 40. Moving the 3 over, you get negative 3 plus log base 2 of 40. Again, change of base for the logarithm. Negative 3 plus, what is that, log 40 divided by log 2. So you get 2.3219, more or less. Or 2.322. You go 3 decimals. And so really what I'm trying to show you here is that to solve a problem that has exponents in the problem, you're going to bring a logarithm to cancel it. This has e. So the opposite of e is natural log, ln. So he's going to get a special logarithm in a minute. But first I got to move the 15 by subtraction. And then I have 4 times e. So now e is raised to the power, not 4. 4 is multiplied. So the opposite of multiplication is division. So 24 divided by 4 is 6. But now because I have e here, I'm going to bring in log of e to both sides. But log of e has a special name. Log of e is really natural log. Log with nothing, log with 10 means logarithm. They kind of go together. So a log with nothing underneath is 10. Natural log is e. In fact, I should put the arrow both ways. So natural log is really log of e. It'll cancel e out, the e. So that's natural log of 6 on the right. This goes away. You have 2x minus 3. Add 3 to both sides, and then divide both sides by 2. So 3 plus natural log of 6 divided by 2. So because this whole thing is dividing by 2, not just the second part, it's with parentheses. 3 plus natural log of 6. You have to close the 6 for the natural log and close the 6 for the top parentheses and divide it by 2. And so you end up with this number, 2.3959, roughly. And then the last one here, I'm sorry, not the last one. Those are the last of the exponential. So now logarithm, to kind of put it next to the exponential. If you have a logarithm, you're going to bring an exponent. So we use log base 2 to cancel the big 2, an exponential 2. So what's going to be a 2 cancellation for 2? You're going to use a logarithm. So you're going to take 2 and raise it to both sides. So 2 to the big 2, the log 2 cancels. 2 to the 5th power, exponential, not 10. 2 times 2 times 2 times 2 times 2, 5 times, 32. Subtract 1 from both sides, that's your answer. So your whole goal is to get the logarithm by itself. So it's not going to make, you can't make this 5 because the 2 is multiplied to the logarithm. So subtract 3. 11 minus 3 is 8. Then divide both sides by 2. You get 4. Now to cancel a log base 5, you need a big 5. So that's the way I call it. So 5 raised to the log of 5 cancels. So x plus 3 equals 5 to the 4th power, 625. And subtract 3 from both sides. And that's essentially how logarithms work. I did a couple more here. Kind of finish up the chapter for us. This one requires subtraction, this one requires addition. So we have essentially condensing into division and condensing into multiplication. So doing the division first, x plus 3 on top, x minus 3 on the bottom. Again, to cancel log base 2, I need a big 2. If this was log 3, I would use a big 3. If it was log 4, I'd use a big 4. If it's natural log, I would use e. Whatever is necessary, you use an exponential to cancel it. So 2 to the 4th on the right is 16. So on the left, you have the fraction x plus 3 over x minus 3 equals 16. But what you do here, you get rid of the fraction. So you multiply both sides by x minus 3, canceling the fraction on the left. So all that's left is a top, x plus 3 equals, and then distribute the 16. Excuse me here, you get 16x minus 48. Now move everything to the left. Subtract by 16x. You get negative 15x plus 3 equals negative 48. Now move the 3 to the right. Subtract by 3, you get negative 51. Over here, you get negative 15x. So divide both sides by negative 15. These guys share a 3 in common. Two negatives make a positive, so 17 over 5, which is basically 3.4. For number 7, again, for number 6, subtraction turns into division. Addition turns into multiplication. Look at the difference. Subtraction, division, addition, multiplication. Minus, divide, plus, multiply. Opposite, opposite. But now here, this is log with no little number. Again, this is multiply, but log with no little number. To cancel this, I need to think of a little number there. So a logarithm with no little base really means a base of 10. ln means base of e. Log with no number means log 10. So I use a big 10 to cancel log 10. Cancel. Distributing these two guys, I get x squared minus 21x. Over here, I get 100. This is a quadratic now. Instead of getting x to the right, to the left, and then numbers to the right, this is quadratic. I have to go back to my knowledge of chapter 1. So I'm sorry, yes, chapter 1. So I'm going, well, actually 1.4. Subtract 100 from both sides and try to factor. So what two numbers multiply to be negative 100 add up to be negative 21? Well, negative 25 and positive 4. Set them each equal to 0. First answer is 25. Second answer is negative 4. Now, the reason that negative 4 can't be an answer is because you can't take the logarithm of a negative number. Okay? It's a non-real answer. The reason you can't take the log of a negative 4 is because the exponential bases are positive. You can't keep multiplying a positive number over and over and over and over and over and get a negative answer. That can never happen. And the same thing with 0. Okay? So you can never get an answer for log of a negative, and you can never get an answer for log of 0. It has to be log of a positive number to get an answer, a real answer. So negative 4 cannot be part of the problem. You can't take the inverse of a negative. That's what I'm talking about. You put negative 4 here and here, you get two logarithms that are negative. That cannot happen. 25 will not give you that problem. So that's good. So this is the end of chapter 4 for us.